Hello class, welcome to Unit 5, Lesson 6. Today we're going to go ahead and look at how to use our graphic calculator to enter matrices, and then we're also going to solve a system of equations using matrices. If you remember in Lesson 5, we learned how, or remembered, or recalled how to solve system of equations using algebra, so substitution, elimination. Today I'm going to show you how to do that using matrices, and also your graphing calculator. So what you're going to want is your graphing calculator. If you do not have a graphing calculator, I'm going to show you some apps that you can download so that you can do this from your iPad or your iPhone. And if you have an Android device, you may need to look up another option. But I think you should be able to put you should be able to put this on your iPhone. So just let me know if you can't. That way we can make sure everybody has a graphing calculator that will function to do these types of problems, because you're going to want one. Okay, so we're going to learn how to perform basic matrix operations, find the inverse and determinant of a matrix, and then write and solve a matrix equation for a system of equations. So if you do not have a graphing calculator, this app, I do believe, works for Apple products. So Calculator X, this you should be able to put on your iPad. So everybody has an iPad. So I would recommend doing that. You can split screen with it. And this one looks the most like the TI-84. Otherwise, there is this other app. It's called Calculate-84. Doesn't look quite as similar to the actual calculator. So up to you which way you want to go. I recommend Calculator X. So if you need to download an app, pause the video, go ahead and do that. Otherwise, go grab your graphing calculator and let's see how this is done. So first things first is we need to know how to enter a matrix onto your calculator. Okay, so here are the steps. I'm also going to show you as I walk through on my graphing calculator. So what we're going to do is, I got my calculator here. Clear out my screen, and then to enter a matrix, you got to follow the steps that are listed on the notes here. So hopefully you can pull up your blank notes and split screen it with your calculator. But you're going to go press second matrix, and matrix is the button. It's actually above x to the -1. Okay, it's above x to -1, which is x inverse. Okay, so I'll actually be using that button later. So I'm going to go second. See how matrix is right here? X inverse. Then what we have to do is, you don't want to click here. We have to go over to edit. Okay, if I go over to edit, and I'm going to hit enter on matrix A. Now here's where I need to put my dimensions in of my matrix. So if I go and look at what matrix A is, this is a, remember, 2 by 3 rows by column. So I have 2 rows, 3 columns. 2 by 3. Okay, and then it should provide me a matrix that is a 2 by 3 in size. And what I'm going to do from here is I'm going to type this matrix in here. So I would do 2 and then hit enter. And that goes to the next, just reads across the row. So then I would have -5 divided by 2 and hit enter. And then the next one is 0, enter. And then I have 0, and then I have 2, and then I have -3. Remember, you guys, if you're ever doing a negative, you have to make sure you use the negative button here. Don't use the subtraction button. And then enter. Okay? Then you should be able to look at it and make sure that it is the same as the matrix on our note sheet. So there's matrix A. So I've now entered in matrix A. Now from here, I want to enter in matrix B. Every time you're done entering in a matrix, you have to go second quit. Okay? So quit is above mode. So second quit. And then I'm going to repeat this process. So second matrix, over to edit. And now I don't want to use matrix A because I already put that one in there. I want to do matrix B. Okay, so if I look at matrix B is a 3 by 3. Okay, so I'm going to go ahead and say it's a 3 by 3. And then I'm going to enter the matrix that was provided. We have 5, -3, 10. And then my next row is 6, 1, 0. And then I would have -5, 2, and 2. Okay, so now I have matrix B entered. Once you have it entered, once again, go ahead, go second quit. If you guys ever need to pause the video when I'm showing you calculator instructions, please do. Make sure you go back, make sure you get it done, because we're going to use the matrices A and B, and then we're going to add a few more as we go through these notes. Okay. So I have those entered. So there's our example 1. Example 2, given matrix A and B, we're going to calculate the following on our graphing calculator. Okay, we're going to do A plus B. So the way you would do this, okay, it works the same with adding, subtracting, multiplying, is I need to grab matrix A. Okay, so I will go second, matrix, and now this time I actually want to use matrix A. So don't go over to edit. This is the names. That's when I can actually use it. So I'm going to do matrix A, and then I just hit the plus sign. Then I go back to matrix, so second matrix. I go down to B, and I hit enter, and A plus B. Error. Why would that be? Well, matrix A is a 2 by 3, and matrix B is a 3 by 3. In order to add or subtract, remember what has to be true about those matrices is they must be the same size. So these two, you cannot do this one. You can write not possible. You can say impossible. It's up to you. But they need to be the same size, remember, to add and subtract. But that's how you would do it on your calculator, and it would provide you with an answer if it was possible. Okay. The next thing we're going to do is we're actually going to take matrix A times matrix B. Okay, so I'm going to hit quit. We'll go down to the next line. So now I'm going to go ahead and grab matrix A again. Remember, the way you grab a matrix is you just hit second matrix, and then make sure you highlight the one you want. I want matrix A, so enter. And then I'm going to multiply it by matrix B. And we probably could save ourselves some time too if we just checked if we could multiply by it, but let's see. There is my answer. Okay, there is A times B. So we were doing rows by columns. Remember we were multiplying before. Now this one has done the work for us. I see there's a decimal. 0.5 is fine. Sometimes we might encounter answers that are not nice decimals, so they go on forever. They're irrational. So what I'm going to do is show you how to convert this into a fraction. So if we want to put this as a fraction, you just go ahead and math, frac, just like you would with anything else. It'll convert the entire matrix, okay, to be with improper fractions. So I'm going to go ahead and write that down. So my answer for B is, what do we got? -5, -17 over 2. Then we had 20. It's just writing down what's on my calculator screen. 27, -4, and -6. Okay, so there is A times B. And now we can do a scalar multiplication of matrix A. Okay, so you could just also multiply everybody by 1/2 if you wanted to. But just to show you how to do it on your calculator, I am going to do 1/2 times A. So 1 divided by 2, or you could say 0.5, times, and then I just need to go grab matrix A. So second matrix, which is above the X inverse, grab matrix A and hit enter. Once again, there's those answers. These answers are fine if you want to write them down. If you want to write them with fractions, we go math, frac. And there is my scalar multiplication of 1/2 A. So my solution for C is 1. Once again, just writing down what I got off my calculator. -5 over 4 is 0, 0, 1, -3/2. So these are my basic operations. So we can add, you could also have subtracted, multiplying, and then scalar multiplication. Okay. The next thing we're going to go ahead and do is a determinant. Okay. So remember, when we do determinants, we need to have square matrices. So 2 by 2s and 3 by 3s. That's what we got for C and D. So let's just enter matrix C and D before we move on, and then I'll show you how to find the determinant. So we're going to go ahead, second matrix, over to edit, and then I'm going to enter this in for matrix C. That's what it's labeled as. You could put it in for A if you want, but we might come back to it later. So matrix C, hit enter, and that is a 2 by 2. So 2 by 2, and then I enter matrix C. So we got -2, 5, 6, and 8. And then remember, once you guys always enter a matrix, you got to go second, quit. Okay. So there's matrix C entered. Now I'm going to enter in matrix D. So it's a 3 by 3. So we go second matrix over to edit again. And now this time I'm going to go all the way to matrix D. It is a 3 by 3. And then I will enter in matrix D. Some of you are probably getting pretty quick at this. You may be typing it in quicker than I am. So I got 1, -2, -4. Next row, 2, -3, -6, -3, 6, 15. And then just remember once again, once you are done, to get out of there, we go second, quit. Okay. So our steps 1 through 3 essentially were how to enter in our matrix. Now, in order to find the determinant, what we're going to do is go to matrix again. Okay, so we're going to go second matrix. Then we're going to go over to math, and then you guys should see DET. That is your determinant. Okay, we're going to hit enter. Then from there, we will go and grab the matrix we want to find the determinant of. Okay, so we are going to, I'm going to clear this out to make my screen a little bit cleaner. To do this, we're going to go second matrix, over to math, so we would go over as using the cursor, and then determinant. Hit enter, and then I'm going to grab the matrix I want to take the determinant of. I want to take it for matrix C, so I'm going to go back to my matrix menu, and then I'm going to actually use matrix C, and hit enter. And it tells me my determinant is -46. So determinant, the answer for this one is -46. Now we're going to go ahead and find the determinant. Remember, these bars mean find the determinant. We're going to find it for matrix D. So repeat that process. We're going to go second matrix, over to math, determinant, so hit enter. And then I'm going to go get my matrix D. So second matrix, and then we're always using the name 1. You can either arrow down, or do you guys see how matrix D is number 4? You can hit 4. It'll grab D for you at that point, and then hit enter. So the determinant of matrix D is 3. So there is example 3. One thing I do want to show you guys is that since we couldn't add A plus B, if you notice, matrix B is a 3 by 3 and matrix D is a 3 by 3. I'm just going to show you how to do that really quickly so you can do adding and subtracting on there if you want to double check an answer on a test or quiz. So B plus D you can actually do. So this is like problem C. So the way we would do that is if we're going to take B plus D, I'm going to go second matrix. I'm going to grab matrix B, which is number 2, plus, and then I just need to go and grab matrix D, which is number 4, and hit enter. And you will see that you will get an answer. The other nice thing is if you guys need to, if you still need to use B and D and you just want to change it to subtraction, you can arrow up, highlight B plus D, hit enter, and then go back over top the plus sign and hit negative, and then you can subtract B and D. Okay, so that's kind of a nice little thing. So your graphing calculator can check a lot of your work for you. All right, then the next thing we're going to do, after determinants, we learned how to do inverses. Okay. Inverses. So to find the inverse of a matrix, what you're going to do is just grab the matrix and then hit x to the -1, because remember, this means inverse. So that means the inverse right there. So you're going to find the inverse of the matrix. Same thing with determinant. Remember, if you get error in invalid dim, what it means is invalid dimension. What it means is that your matrix is not square. It's not the right size. Okay. The other thing is if you get error singular mat, it means singular matrix, there is no inverse. Okay, so if you get an invalid dimension, you can't do it because it wasn't a square matrix. If you get this singular mat, it means that the matrix has no inverse. Okay, so that means you had, what do you guys remember when we had no inverse? We had 1 over, we did AD minus BC, and then we had our D and B switched, and this would have been negative, I swapped that around, sorry. This would have been A and D. This would have been negative B and negative C. And when we did not have an inverse was when your determinant, this part right here of your 2 by 2 equaled 0. So if AB minus BC equals 0, then you cannot find the inverse. Because you cannot divide by 0. So if that happens, there is no inverse. Okay? So first thing you always check when you're finding an inverse, it's got to be a square matrix. If it is square, you can find the inverse. However, if you get another error, it means that the determinant was 0, so there is no inverse in that case. So let's go ahead and find C inverse. So the way we do that is we go ahead, grab matrix C. So second matrix, grab matrix C, which is 3. And then to get inverse, do you guys see where we've been pushing matrix the whole time? We just hit the inverse button and then hit enter. Oof, those are some irrational numbers, so I'm going to put those as improper fractions. So I go math, frac, and hit enter. And there is my inverse for C. So I'm going to write that down so that I have it. Okay, so C inverse is, whoops, I had -4/23, then I had 5/46, 3/23, and 1/23. There is C inverse. Let's go ahead and do D inverse. Repeat that one more time. So I'm going to go ahead and grab matrix D. So second matrix, going down to matrix D, which is number 4, and then inverse, and hit enter. Same thing, I got some irrational numbers. You guys probably know what those ones are out of the top of your head. This is -2/3, and this would be 1/3, but I'm going to go ahead, just to make sure I was right, math frac, my pal, and then go ahead and write that down for my inverse for D. So we would have -3, -4, 1, 2, 1, 0. This was -2/3 and then +1/3. So there's my inverse for matrix D. Okay, so there's that. So those are my basic operations along with finding determinant and inverse. If you have any questions about any of that, please let me know. Otherwise, we're going to go ahead and solve a system of equations with matrices. So step 1, we need to take our system, okay, our equations that have x and y's in them, and write them as a matrix equation. Okay, so what we got is we have our coefficient matrix. Okay, so before we even write a matrix equation, we need to make sure we have all of our x's lined up, all of our y's, then equals, and then our numbers that are not associated with the variable. Okay, then what we do is we do our coefficient matrix. So the coefficients are the numbers in front of the variables. We take those and we put them in the coefficient matrix. Then we go ahead, whatever variables we are working with, and we put them into the variable matrix. Okay. And then we say equals. And then lastly, it equals the constants, the numbers that were by themselves. Okay, so we got 6 and 8. That's our constant matrix. The reason this works is, if you remember, when we have row by column, if this is a 2 by 2 and this is a 2 by 1, I can multiply them because this matches up, and my result will be a 2 by 1. Okay, if I were to row by column multiply these, I would take 5 times x, and in between I would add plus -4 times y, and then I would move on to my next row, okay, because my final answer is going to be a 2 by 1, so 2 rows, 1 column, and so I do row by column. I'd have 1 times x, so 1x, plus 2 times y, and then that equals 8, 6. If you guys take a look, it brings me back to where I started. Okay, so there's that. Okay, so this is what we call our matrix equation. So let's practice doing that. Pretty straightforward. So first thing we do is we write down the coefficient matrix. So it is 5 and -6. Don't forget the negative if there's one in front. 3 and 2. And then the next matrix is our variable matrix. I'm working with x and y. And then it equals my constants, my numbers by itself, -47 and -17. So for A, there is our first matrix equation. Okay, B, let's repeat. We'd have 2 and 3. Then I have 4, and careful, this is a -1. Then it's my variable matrix, so whatever variables I'm working with, x and y. And then that equals 7 and 6. And the last one, 3 by 3, but same idea. Okay, just all of our x values in a column, all of our y values, and then our z's. So I got 4, -2, 1 for x's. Now my y's, -3, -1, -4, -3, -1, -4, and then z's. 2, 1, -1. And then my variables this time, there's 3 of them, so I got to write x, y, and z, and then that equals my constants. 10, 4, -12. So there are my matrix equations from my system of equations. So that's step 1. Okay, let's do a little bit of practice with even just a word problem. So in chemistry, the molecular formula for glucose is C6H12O6, which represents the molecule of glucose, which has 6 carbon atoms, 12 hydrogen, and 6 oxygen atoms. 1 molecule of glucose weighs 180 atomic mass units. Okay, so all of that information is basically laid out in this chart here. Then it also proceeds to tell me that 1 oxygen atom weighs 16 atomic mass units. The formulas and weights for glucose and sucrose are listed below. Okay, write a system of equations that represents the weight of each atom. Okay, so let C represent the weight of a carbon atom. Well, that's C. And H represent the weight of the hydrogen atom, which is just our H in our formula. Okay, so the way I'm going to do this is I'm going to write one for glucose. So glucose. Well, there's 6 carbons, so 6C, because I don't know the weight of a carbon, plus 12H, because I don't know the weight of a hydrogen, plus 6 times oxygen. The problem told me how much an oxygen one is, so 6 times 16. And if I add up those 3 atoms, it weighs 180. Okay, there's kind of my first step for glucose. Now we do the same thing with sucrose. I got 12 times my carbon, plus 22 times my hydrogen, plus 11 times the weight of oxygen, which is 16. And that will equal the total weight, which is 342. Okay. Now from here, I am going to eventually write a matrix equation. So I have to have my variables lined up and then all of my numbers lined up. So what I'm going to do is figure out what numeric value 6 times 16 is. So 6 times 16, I should get 96. And 11 times 16, I get 176. And so these are constants. They're numbers without variables. So I'm going to move them to the other side so that I can write a little bit better system of equations, which will help me write my matrix equation. So I will still have 6C plus 12H equals, I would take 180 and subtract 96 to move it to the other side. So 180 minus 96, I get 84. And then I go ahead and I would do the same thing with sucrose. So I would have 12C plus 22H equals 342 minus 176. You should get 166. So this is my system of equations. Okay. Sorry about my dogs. All right. So we need to write a matrix equation. So we're going to take the coefficients, put them down first. So I would have 6, 12, 12, 22. Then I have my variable matrix. So my variables this time are not x and y, it's C and H. So CH, and then it is equal to my constants. Okay, so there is an example with a real life application or word problem setting up your matrix equation. Okay, so that's our step 1 in how to solve. Now we're actually going to solve using matrices. Okay, before we do that, let's go back to something we know. In order to solve AX equals B, this equation right here. Let's go, I'm going to say it's 3x equals 15. Our goal is, you guys, to get x by itself. Okay, so what we want to do is get x by itself. The way I would do that is, this is 3 times x. The way we undo multiplication is by division. Okay, the other way of writing division is multiplying by 1 over that value. So I'd have 1 over 3 times 3x. And we do that on both sides. So I'd have 1 over 3 times 15. Well, 1/3 times 3 gives me 1, so I have x equals 1/3 times 15, which is 5. Okay, so that's our process in getting x by itself. We do the inverse of multiplication, which is division. Okay, a lot of times you guys like to see it written this way. We'd have 3x equals 15. So how do you undo multiplication? We divide by 3. Okay, now we have matrices. This is matrix A right here. How do we undo matrices? That's their inverse. We undo them with their inverse. Okay, so what we do is, in order to get rid of matrix A, I multiply both sides by A inverse. Okay. Remember, A inverse times A. When you multiply those two matrices, you'll get the identity matrix. 1, 0, 0, 1. So essentially, A inverse and A cancel each other out. So all we are left with is our variable matrix. Okay? And when you take the constant matrix times the inverse matrix, you will get what x is equal to. Okay. Let's actually do this using example 7. So step 1, write out the matrix equation. This is what we got done doing before. So matrix equation, so our coefficients, 6, 3, 2, negative 8. Then I got my variables, x and y, equals the constants, so 11 and 1. Now, what I want to do is I want to get rid of this matrix because I only want my variables. The way that I get rid of it is I multiply both sides by its inverse. Okay, so step 2, multiply. I'll write it out. Multiply both sides by its inverse. So remember, order matters. Okay, so when we multiply, we're always going to multiply it on that left-hand side. Okay, so I will now have my inverse. It's 6, 3, 2, negative 8. And I'm just going to use the notation for inverse. This matrix, its inverse, times our coefficient matrix. Then we got our variable matrix. And since I multiplied the left-hand side by the inverse, I need to also multiply the right-hand side equation by the inverse. But remember, we got to do it on the left because order matters. So I got my inverse of 6, 2, 3, negative 8. And then I got my constant matrix. So, based off what we know about our inverses, the inverse of these two will cancel each other out. And all I will be left with is xy is equal to the inverse of our coefficient matrix times 11, 1, my constant matrix. So we're going to go ahead and do this on our calculator. Okay. In order to do this, I need to enter in both of these equations. I'm going to put them in for, I'm going to call them A and B. So I'm going to let this one equal A. And this one will equal B. And A, notice, is a 2 by 2. And B, rows by columns, 2 by 1. Okay, so let's enter in A and enter in B. And then let's actually calculate it. So we're going to our calculator. And I'm going to go to my second matrix, and now I want to enter them, so I have to edit them. So I'm going over to edit, and I'm going to hit enter. I'm going to put it in the spot of A. So our first matrix is a 2 by 2. So 2 by 2. And then I'm going to type in what our original coefficient matrix was. It was 6, 2, 3, negative 8. Okay, and every time after I get done entering something, I always go ahead and second quit. Now I'm going to go ahead and enter my other matrix, which is matrix B in this case. It's a 2 by 1. So I go second matrix over to edit, down to B. This is a 2 by 1. And I'm entering in matrix B. That was 11 and 1. Okay, once again, once we get done editing, we go ahead, second quit. And now I go ahead and I'm going to calculate what is xy equal to. So I take my matrix A, the inverse of it, times my constant matrix, my 2 by 1. So I go ahead and grab second matrix A. I want the inverse times matrix B. And I hit enter. And I see that I have my answer here, but I'm going to go ahead and put them as fractions. So I go math frac. I got 5/3 and 1/2. Okay, so when I calculate this, I have xy is equal to, I had 5/3 and 1/2. So what does this tell me? This tells me my answer for x is 5/3 and my answer for y is 1/2. So my ordered pair is 5/3 and 1/2. So there it is. You could solve this matrix using matrix equations. Okay, you could also do it using substitution or elimination. But here's how you would do it using matrices. Let's go ahead and look at another one. 8. Use a matrix equation to solve the system of equations. So first things first, set up that matrix equation. Okay, so I have 6 and 8, -9 and -12. Then it's your variable matrix, so be careful. This is A and B, not X and Y. And it equals -18 and 24. Step 2, I'm going to shorten up my writing a little bit here. I want to get rid of this matrix. So what I will do is multiply both sides, let's say this is matrix A, by its inverse. Okay, so to get AB, what I need to do is A inverse. So I'm going to rewrite matrix A, but I want the inverse of it times this matrix here, -18, 24. Then from here, I just need to type it in my calculator. So let's go ahead and do that. I'm going to use matrix A and B again because I already have their dimension set up. I'm just going to copy right over top of them. Okay, so go into my calculator. So we go second matrix over to edit. Matrix A is still a 2 by 2, so that's good. And now for this problem, we got matrix A is 6, -9, 8, -12. Okay, then I'm going to go ahead second quit. And I'm going to repeat this process again, but with my matrix B, which is a 2 by 1. Oh, shoot, I don't want to grab B. I didn't want to grab B. I wanted to edit B, didn't I? So second matrix over to edit B, 2 by 1. And then we would have B was -18, 24. Okay, now second quit to get out of there. And now I need to take my inverse of matrix A times matrix B. So I grab second matrix A inverse, so I hit the inverse button, times B. So second matrix and grab matrix B and hit enter. And I get singular matrix. So what does this mean? We talked a little bit about the singular matrix error before. This means that no inverse matrix exists. Okay, so this means we can't solve it. It either means no solution, or our other option is infinitely many solutions. Okay, so if we get that error, you need to determine if it is a no solution or an infinitely many solution. So let's see, I'm going to make a little note here. We got an error. And what this means is no solution, or it means infinitely many solutions. So to determine if it's a no solution or infinitely many solutions, find out, we use algebra. Use algebra to check. Okay, so I'm going to go and use elimination. Let's look at my A's. I can make 6 and 8 both multiply to be the number 24. Okay. So I'm going to take this one times 4 and the bottom one times -3. I'm going to take and rewrite all of this down here. So what do I got? 4 times 6 is 24A minus 36B equals, I didn't write the B, 36b equals negative 18 times 4 is negative 72. Now I'm taking my whole next equation times negative 3. So I got negative 24a plus 36b equals negative 72. And remember, when we do elimination, we add. My a's cancel and my b's cancel. So I have 0 on the left-hand side equals negative 72 plus a negative 72, negative 144. So is this a true statement? No. So if it's not true, remember this is a no solution. If you would have gotten 0 equals 0, that's always true, so that's infinitely many solutions. So if you get an error on your calculator because your inverse doesn't exist, you need to go ahead and use algebra to check if it's a no solution or an infinitely many solutions. Okay. Let's give one more a try, and then we can go from, and then I think we'll be good from there. So use a matrix equation to solve each system. So step 1, set up that matrix equation. So we got our coefficients, negative 2, 4, 3, negative 8. Variable matrix, x and y, equals our constants. So we got negative 7 and 16. Then from here, I want to get x, y by itself. So the way I do this is, if this is matrix A, I would multiply both sides by A inverse. Ignore that little spot there. A inverse. Gotta do it to both sides. Those will cancel out. So our step 2 is that xy equals our A inverse. So it's a matrix. That's my A inverse times negative 7 and 16. And now from here, I just go ahead and I use my calculator to figure out what my product, or what I get when I do the product of those two. Okay, so go into my calculator. I'm going to hit and quit. I'm going to clear out what I got here, and once again, I'm going to go plug in my new matrix A, plug in my new matrix B. If you guys wanted to put the matrices in other spots, other names, you can. I just think it's convenient to use A and B because they're at the top. So my 2 by 2, we got negative 2, 3, 4, and negative 8. Then remember, we always got to go second quit. Quit's above mode. Then I go back into matrix, over to edit, down to B. I got 2, 1, and my B matrix in this case is negative 7 and 6. Okay. Now to get out of there, once again, I go second quit. And now I will actually, now that I have the information entered, I'm going to do A inverse times my B. So I got to grab A. So I go second matrix, not over to edit, stay at A. So I want to grab matrix A, then it's inverse times matrix B. So second matrix B. And there's my answers. I am wondering, did I enter in something right? I have something different on my paper, but I could have made a mistake when I wrote it on my paper. I'm really quickly going to check. So if you ever want to check what you have in for a matrix, we're going to go matrix A and just hit enter. I should have negative 2, 3, 4, negative 8. So that is good. And then matrix B, so second matrix, go down to B. I have negative 7 and 6, so there's my error right there. So if you ever want to check a matrix, you guys, just go second matrix and check it. So I just missed that it was a 16. So I'm going to go and edit matrix B. So second matrix, over to edit, matrix B. Hopefully you didn't make this mistake like I did. So we got negative 7 and 16, hit enter. Now get out of here, second quit. Now I could go ahead and do that, but I think if I just arrow up and grab A inverse times B, it should work out. And yes, this is the solution that I have written down. It should be 2, negative 1. So I get 2, negative 1. And so what this tells me is my x is 2 and my y is negative 1. Okay, there's my answer, for example, 9. If you would like, there is a your turn, so if you just want to practice one more, you may. If you feel good, you can move on. The solution for this one is 7, 3 though, okay? You'd set it up very similarly. You'd have 1, 1, negative 2, 5, xy equals 122. And then in order to get xy by itself, I'd multiply both sides by the inverse of this matrix here. So if you wanted to type it in your calculator and get that practice, you can. Otherwise, you do 1, negative 2, 1, 5, the inverse of it, and then times your constant matrix, numbers that were by themselves. And that should lead you to this result here. So there's the your turn. If you have questions, feel free to message me, sign up for an office hour time, come on in, and we can go from there. Otherwise, your assignment is to complete the worksheet. Feel free to use your calculator on all of it. Okay. If you have questions, let me know. Otherwise, have a great day.